Hi everyone. I said a couple things during this presentation that weren't exactly correct, but I straightened all that out in the annotations. So if you don't already have the YouTube annotations on, you should turn them on. If you have any questions about stuff that I said in here, or if you notice anything that's wrong, please feel free to hit me up down in the comments section below. All right, enjoy. And I'm recording. Okay, everybody. So I'm Mercury the White, and this is the Intro to Programming number 1 out of 2 for the Novice Now Jam, and hopefully we'll be able to learn something. This is actually, I started writing this. I wanted it to be one jam, or I wanted it to be one presentation, but it turned into something really long. So I actually had to cut it in half. So here is what we're going over today. Items 1 through 4 actually, I'm sorry. That's actually wrong there. Functions and scope is out of our scope for today. So let's get started. So this is a tour of programming. It's not a full course. I've basically taken an entire college course, Programming 101, and compressed it down into a single slide deck. So this won't be complete, but hopefully it should give you an idea of where you can, it should be a jumping off point where you should be able to learn on your own, look stuff up to see. So, but if you have any questions, you want me to elaborate on anything, hit me up in chat. Or send me an email. You guys should all have my email, and I'd be happy to, talk your ear off about anything. So step 1, of course, the first step is thinking like a programmer. So we're gonna try and understand that programming languages are very different from natural languages. So a natural language is any language like English or French or whatever, and it is ambiguous. Natural language is inherently ambiguous. You say things like a handful or a bit of something or several or a little, and that's just completely meaningless to a computer. And it's one of the reasons why natural language processing, which is like what Watson, the Jeopardy playing computer, why it needs to be the size of several refrigerators just in order to function and answer your questions, and why Siri and all that are such powerful pieces of software. In a programming language, you must be specific, and it means you really have to sit down and buckle down and think about what you're doing in order to state the steps to solve your problem in the most clear way possible. Now that sounds a little stuffy, but it actually can be a lot of fun, and it's one of the reasons why programming can be appealing to some people, because it can be like playing a brain teaser, trying to express algorithms in a good way. Now, the other major pitfall, especially when it comes to games, the problem with games, and it's something you can overcome, but the first barrier of entry to programming a game is it seems easy. And I don't want to scare anybody off. It's very rewarding to make games, especially if you are in for a challenge. You're a masochistic kind of person like me, then you're going to love to hate it. And one of the first times it struck me at seemingly simple things being complicated was collision detection. In the real world, if you grab something, your hand is going to stop when it hits it. And it's such a natural thing for humans to expect. It's something you take for granted. And it is not at all a trivial problem when it comes to games. You can take a look here at collision volumes in an FPS. You can see there's a guy here, and he has a pill-like collision volume around him, which is how do we figure out if this guy's going to get shot? And it seems obvious, did the bullet hit him, but it's really not, because it has to be done very quickly, and it has to be done in real time. So the first thing that happens when you try and shoot this guy is it sees if it intersected with that pill that he's sitting in. It's called a collision capsule, and it does very loose grain. It's a very quick and easy way to figure out whether or not he's been hit. And if it does that, then you'll see that there's another set of meshes around his various body parts that get checked. And then it checks all of those. It goes in and you do the collision detection. If it passes the capsule test, it checks all of those. And that's going to let you know whether he got hit in the head, whether he got hit in the arm, or anything else like that. You can see that they're all various complicated objects that are as simple as possible to make collision detection as efficient as possible, but loosely represent each of the objects. And even if we get a hit on that, then we're not done, because you can see around his head there's lots of space. He's got these huge ears that stick out that wind up making his head collision volume pretty wide. So you're not even done after that. After that, if you pass the capsule, if you pass the head, then it actually goes into his complicated mesh, or there might be a simplified collision mesh that they're using. And it does very fine grain and expensive collision detection to make sure it actually hit his model. And there's just so much that goes into this, and so much math that it can be kind of overwhelming. So this is a specific example, but the point is that programming problems, especially in games, can be deceptively difficult. And you should never just jump into something blindly. Otherwise, you're going to wind up realizing that you're programming in such a way that you might have a bad design and have to start over. And one of the things that is the most expensive in software development is when you make a bad design choice, or you make an issue and it gets carried on. Let's say that you start making your game and you make a bad choice with collision detection, and because you weren't thinking or whatever. And then you go down the line and suddenly you've got levels done and you've got all of this player code written that relies on the way that your collision system works, and suddenly you have to change the collision system. That's going to be huge. There's actually been tons of studies in professional software development, like for businesses, that show that the later and later errors persist through a code base, means that the cost of fixing them becomes exponentially more expensive. So by taking the time to plan is going to be way cheaper in terms of time and resources than fixing will. They say that for every minute you spend planning, you save 10 times that, or something like that, in fixing stuff. So that's just a quick overview of thinking like a programmer, and by no means is that all of it. So now we're going to dive into data types. So data types. What is a variable? So a variable is, and this is really hard to come up with a definition for, but you can think of a variable as a named piece of paper. You can write something down on it, you can read the information back later, you can erase it, you can replace it with some other information you choose, but most importantly, you can refer to it by name. And now if there's any advanced programmers out there, I'm sure that you're going to have objections to this loose definition, but hopefully it will it'll serve to at least give you a starting idea of what a variable is. And they are one of the most basic components of software. So what can you put in a variable? There's lots of built-in data types, which are called primitives in most languages, and for the most part they're all the same. You're going to have integers in any programming language. You're going to have, in just about any programming language, that's I can't say all, you're going to have booleans, floats, and hopefully you can see here that all of this stuff you're seeing on the screen in the Zelda screen cap is stored as different data types, and there are good data type choices and there are bad data type choices. For example, his rupees, the rupee number, would be a bad thing to store as text because you've got to change it, and you do math on mathematical types. So you only want to turn that number into text when you need to print it to the screen. So so hopefully we'll be able to take a look at what different data types we can see here. So let's see here. So we see some numbers, some numeric types up there, right, being the bombs and the rupees and the arrows. The number of hearts, that can be represented by numbers. You can have two numbers for each heart, because I believe you can have half a heart. I think that's what you see there. Over there, you've got the magic, which would be a float probably, which is a number that's a decimal point, because floats work well for percentages. And that magic bar is probably, the amount of magic you have in that magic bar is probably being stored as a percentage. You've got 80% left or something like that, which means that you'd probably be storing that. Now also, if you're really clever, you're going to notice probably that the tiles that everybody's standing on, yes, 69 arrows, almighty, very, very, very clever. And the tiles need to be represented too, and they are actually represented in memory as a 2D array of numbers, what the tile type is. So this grass is going to be a specific number, and then this wall is going to be a specific number, the trees. So let's dive in and actually see what these different data types are. So we are starting with integers. It's one of the most absolutely fundamental data types. And it is an integer. That's what an int stands for. And an integer means that there's no decimal points. And integer division will sometimes bite you in the ass if you need decimal points. Yes, Kretz, this is going to be uploaded to YouTube, and I will, you can send me a message or give me your email address or something like that, and I'll be able to hit you back with information about that too, what the YouTube channel is. Integers can be positive or negative. It's called being signed, as in the positive sign, the minus sign. That's what signedness is. So you can have that, and obviously anything in the computer, one of the limitations you're always going to be struggling with, you always have to keep in mind, is your size limit. So one of the limitations on any computer program is your size, also known as your resources, and what the complexity of your algorithm is, how hard it is to do a computation. And those are always things you have to be juggling. And for that, there is an entire Crayola box of varieties of different integers. You have ints, shorts, longs, unsigned ints, long longs, unsigned long longs, unsigned shorts, all of this different stuff. And so just really briefly, an int is the normal size, a short is smaller than that, a long is larger than an int, and by larger I mean you can store a bigger number. You can store a more positive and a more negative number. So you can store negative 3 billion whatever up to positive 3 billion whatever. And the way that this works is 0, the number 0, is somewhere in the middle of this, and the way that the number is actually stored under the hood is by something called 2's complement. And that's 2's complement in chat. So that's going to be confusing to see that in chat until you realize what the heck I'm talking about. Now what happens if you have the largest integer you can possibly have and you add it to itself? Is that legal? Well, yeah, that's actually going to be legal. Some languages are going to throw an exception or an error that you can handle. They'll call it an overflow error. In languages that don't handle that, if you add two gigantic positive numbers together, it's going to become a negative number. It's going to wrap around. And that's because of how the 2's complement storage mechanism works. And I'm not going to go down into that, get into those details because they're pretty low level. Though you should definitely know about it if you're really serious and interested in building yourself a good foundation, because it's actually fairly important. Now, unsignedness, the way if you want to have a really big positive number, you can make your integer unsigned. And that takes away the entire negative half of the spectrum, which in effect doubles the size of the integer that you can use. Because there's a fixed number of bits that the number is represented by. There's a fixed number of possibilities, or a fixed number of ways you can hold up your fingers to represent a same number. And by getting rid of the negative parts, it doubles the largest positive number that you can use. So this is a lot. There's a lot going on behind the scenes in integers, but hopefully this should give you a brief introduction. And if any of this sounds interesting, or you suddenly see weird stuff happening in your integers when you're writing code yourself, you'll be able to come back to this and maybe direct yourself to the solution. Oh, and if you're interested in how integer division works, if there's a decimal point, then it works by truncation, which means the decimal point is just cut right off. So that 3 divided by 2, you're going to have a decimal point. It's going to be 1 point something. And it's not rounded up. It's not rounded down. It's just cut right off, and that's called truncation. Now, what if you do want a decimal point? You can use a float. In some languages, they call these numbers. And in some languages, you don't have ints. You just have numbers, and that's it. You're stuck with floats. And it's a number as opposed to an integer. It has a decimal places. There's a maximum precision. And it basically behaves in the exact, it's positive and negative, and it behaves in basically the same way as any, here one sec, my computer is being weird, okay. It behaves in the exact, you can do the same kinds of operations you can do with an integer on a float. And if you have these great things, then why don't you use them instead of integers? And the reason is because float operations suck. They're slow and shitty, and they're the slowest data type to operate on out of the built-in data types. There's a bunch of tuning you can do if you need to represent your numbers in floats. There's compiler options called fast float, where it gives you less accurate float results in your math, but it speeds it up. It speeds up the float operations. The worst thing you can do in math is to divide two floating numbers by each other. It is the slowest operation you can do with a basic data type. So if you can use integers, use integers. If you need the precision from a float, you're always going to need precision from a float. Character positions in a game, if you're not tile-based, like you'll notice in Pokemon, everything is tile-based, and the benefit that gives you is you don't need to use floats to deal with character position. You can use integers, and you can use a fixed grid is what it's called, where you have to be exactly on one grid position. At any given time, you can't be between them. And that allows you to use ints, which are significantly smaller than floats too. So floats are bigger and slower. And the way that they're stored in memory is actually pretty complicated. So I'm not actually going to get into that, but you can look that up if you want to. In addition to all that, they have underflow, which is an interesting issue where eventually you can store a fraction that's too small to be represented as a float, and that is called underflow. And that's a whole nother issue to deal with, but it's also pretty obscure. Finally, you're going to see some wrong answers sometimes when you print a float. It's pretty weird. A float inaccuracy, just by the sheer merit of how it's stored in memory, sometimes the result of your float division it's just gonna be wrong. And that has to do with the precision. It has to do with how the number is stored under the hood. So if suddenly you see that, it has to do with the float representation. And so don't panic, your computer's not broken. Now let's talk about a Boolean. A Boolean, or a bool, is simply true or false value. And it is the smallest possible thing you can store in memory. Because computer memory is, as you may know, is stored in bits. It's 0 or 1 off or on little switches, and memory is just an infinite well, it's not, it's a gigantic sequence of these off or on. And a Boolean, since it's only true or false, it's only got two possibilities, can be stored in a single bit, which means that that they can be very efficient to be operated on. Boolean operations, checking if two Booleans values are the same. I think that checking if a Boolean is equal to 0 is probably one of the fastest operations you can possibly do on a computer. Compilers are extremely, and processors are extremely good at doing that. Boolean results are always going to be one of the fastest things you can do, and bitwise operations. There's a whole set of operations aside from addition and division and multiplication and all that. There's also Boolean operations that you can do, which I'm not going to get into because they're a little bit more advanced, and they're extremely fast. So if you can use a Boolean, where you can, use a Boolean. Oh, and also comparisons. If you're using an if statement or something like that, if you're already familiar with what that is, then the body of the if statement has to evaluate to a Boolean in order for the conditional to work. So how do you deal with variable? We've gone over a whole bunch of different data types, and here is some C, C++. I don't know if I mentioned this before, but I'm going to be using the C, C++, because it's very general. I'm going to try not to be doing anything that's C specific, so you should be able to generalize all of this information to just about anything except for, untyped languages. So here we go. We are declaring an integer whose name is n, and we're going to set it to 7. And what this is going to do under the hood is you're going to have a little bit of memory who is integer sized because you are asking for an integer, and it's going to put a 7 in there. And so you're going to be able to now refer to it by name. Its name is now n. You can refer to it without its type. Afterwards, the next line is going to set it to 8. So now the same block of memory inside your computer is going to be replaced by the value 8. And then you can refer to that space that's referred to by n. You can now refer to that there. Now you see another operation here. It's a little bit more complicated. It is, you're going to start on the right. You're going to start reading this on the right side. So the first thing it's going to do is you see the n on the right side of the equal sign, and it's going to read that out of memory. So it's going to pull 8. It's going to see 8. And it's going to say 8 plus 1. And that's going to evaluate to 9. Now just adding it on the right side there is not going to save it. You have to explicitly request that it be saved. What happens when you just add it is you create this transient value that isn't stored anywhere, and it can be put somewhere else. And right now we're going to be putting the result of that arithmetic operation back into n. So now we have 8 plus 1 is 9, and we're going to store it back into n again. So now we have 9 saved in there. I see I got a question here from L. Dodson. I don't see what that is in response to. I'm probably a little bit ahead of the stream at this point. So let me know specifically what you're asking there. I'm going to give just a minute for the stream to catch up. Going a little fast, I think. We're sitting around 25 minutes in. Let me know if anybody has any questions so far, because we're going to be going into control structures after this. Yep. You'll notice that all of the statements here end with semicolons. That's pretty standard to end statements with semicolons. There's almost every language will do that except for scripting languages. Python, you don't need semicolons in. You don't need it in Lua. I don't believe Java requires it either. JavaScript requires it either. Java does require it. It's not a scripting language. Okay, well, L. Dodson, if you have any questions or anything like that, you just hit me up in chat and I'll get to it after the next section. So diving right into control structures. So, what is a control structure? Control structures are mechanisms which are going to allow us to dynamically select. So in other words, based on some sort of logic that we choose, that's what I mean by dynamically here. Could be something that differs, for example, based on the value of a variable. So maybe we'll say if the value in n is even, or it's odd, or it's bigger than 10, or it's less than 2, or it's positive or negative, then we're going to do one thing as opposed to doing something else. So for example, in a game, let's say that we have some logic to decide what happens when the player pulls the right trigger in an FPS. Well, we can't just say shoot the gun, because what if they're out of bullets? So we'll have a control structure. We're going to have an if statement that says if you are out of bullets, then don't shoot the gun. Just make the click noise. Just go instead of actually initiating the firing code to create the bullet and cast the ray and decrement the clip and all that. So let's dig right in. We're going to be looking at some various control structures here. Oops. Various control structures here. There's the if, else if, and else. There's switch cases. There's while and for. We're going to be talking about those first four up there. Additionally, there are the ternary operator. There's do whiles. There's jumps. There's ranged fors. There's all kinds of stuff. There's more complicated control mechanisms such as event-based. Event-based, I don't know what you would call it, the event-based paradigm, I suppose. But event handlers, there you go. Handling events and stuff like that are a little bit out of the scope of the basic stuff. But the first four, well, number 1, number 2, and number 3 and number 4, you're going to see in just about every language in existence has if, else, while, and for. Switch case, not so much, because it can be handled as a complicated for loop. But let's dig in and let's see what the first one is. So the first one is an if statement. If statements are the most basic control structure. If statements only execute the instructions inside its braces. So you can see there's the little squiggly parentheses, they're braces. Right after the if is raining on the right side here. It's also called its scope. Scope is another idea that we're going to be talking about in part 2 when we talk about functions. But right now scope is out of scope of our conversation. So it only executes its body if the condition is met. So we can see up here, we have a little code snippet which translates in English to, if it's raining, pick up an umbrella before you leave. So it's very simple. So first we're going to initialize a Boolean. That's what bool stands for. It's named after Charles Boole. He was a logician guy. He basically laid the foundation for formal logic. He's kind of an important guy. We have a Boolean called is raining, and we're going to set it to be true. The way that you say true and false in a lot of languages, actually, there's variation. Sometimes it's all caps, sometimes it's just the first letter. C doesn't even have, the initial version of C doesn't have Booleans at all, which is extremely unusual. It's kind of very archaic feeling. But here, this is the C++ allows you to use true and false as all lowercase like that. With Booleans, true is going to generally be equivalent to 1, and false is going to be equivalent to 0. Remember, we were talking about how they're bits, they're represented as single digits that can only be 0 or 1. Well, 1 or on or set or true, they're all the same thing. You'll say the bit is set if its value is 1 or its value is true, or it's unset if it's 0. So in here, the if statement's condition is very simple. Is the is raining. It's just a simple Boolean. There's no comparison, nothing else like that. It's literally just a Boolean. So immediately we know that the value of is raining is true. So we're going to get the umbrella, and you'll see I've got these 2 slashes. They mean a comment, which means that it's just annotation for the programmer, and when the actual code is turned into a program, it's just completely ignored. It's treated as blank space, and it's just for your own reference. And since we haven't gotten into functions or anything like that, then I don't actually have any code in between the braces. So we are going to, since it is raining, we're going to get the umbrella, and then we leave the body of the if statement. So regardless of whether it was raining or not, we're going to leave. We're going to go outside either way, because leave is outside of that brace there. You'll see that here I'm using what's called Egyptian braces, where there's one up in the top right and there's one in the bottom left. I'm following the Google C++ style guide for this entire presentation. So if you're interested in writing clean code, and you should be, you might want to take a look at that because it's a really fantastic resource. One of the #1 things I have to recommend to you if you ever get into professional programming is do not bring your own style to somebody else's code base. You will piss off the lead programmer if you start suddenly writing code your own way instead of theirs. It's always best to be consistent. And it's also, it looks very good if you're ever given a code test for a company. You should ask to see their style guide. They won't give it to you, but you should always ask because it means that it shows that you care. Moving right along, we have our if-else statements. So an else statement allows you to explicitly have another body full of statements to execute if your condition is not met. So in this case here, we're going to say go to work if it's a weekday or sleep in if it's not. So you can see here we say it is a weekday. We have our Boolean up there called is weekday, and we set it to true. And in the first brace, or the first body here, we have, I'm sorry, just setting my Skype. I forgot to turn it off because I'm a noob. We have go to work. But if it wasn't the case, if I went back there and I changed if is weekday to false, then it would say is weekday, and it would jump in, and since there's an else clause, is what it's called, it's a clause. Since there's an else clause, we're going to jump into the else clause body. Don't call me a noob. So you can even have more. You can have if else. So now we've got multiple cases here. Now right here we're going to see a pretty standard way of very succinctly representing different possibilities. There's Booleans, which can only be 2 values, which can be limiting if you're trying to handle multiple different cases. So let's say that you wanted to handle what kind of gun a player has in their inventory, or what's inside of a box. Instead of using text to do that, you could use a string if you're familiar with strings, which aren't always basic data types, so that's why I didn't cover them. Then you can store, if you're willing to come up with a meaning for different things, and you can store it in a very small amount of space as numbers, as an integer. In C++, we have something called an enumeration. I'm going to write that in chat. An enumeration, or an enum, is actually what the structure is typed, and it's basically just an abstraction of this concept of using a number to represent something. You can use it to represent error codes, weapon types. The kind of tile that the player is standing on is usually represented as a number. All sorts of different stuff. Representing them as numbers is usually a very good idea. So now, let's say that we need more fine-grained control over what we're going to be doing. And here we've decided that we've declared our meal to be encoded as 0 if it's breakfast, 1 if it's lunch, or 2 if it's dinner. So now we have an else if clause because there's 3 possibilities. So first off, we're going to be setting it to lunch. So if it's lunch, we're going to say if 0 is meal, and it seems kind of backwards. I'm going to tell you about that. It's called a Yoda statement, but we'll get into that in a second. Then we're going to eat breakfast. Now, that's not the case. Meal in our case is 1. So 0 equals 1. That's a comparison. It checks to see if the 2 values are the same. And 0 equals 1 is false. 0 is not 1. It's different from 1. So it's going to evaluate to false. So we're going to drop down to the next possibility in this if-else block, is what it's called. And so now we say else if 1 is meal, which it is. It means it's lunch. Then we're going to eat lunch. And now you'll see here I'm not doing a comparison for the last one because we have agreed that there's only going to be 3 possible values of meal. So there's no need to do the check. By avoiding that check, then the compiler doesn't have to do that operation. It doesn't need to do that comparison. If those checks are really expensive, then you don't want to be doing them over and over again as you move down, as you fall through, is what it's called, fall through the if block. So since we can avoid the last one, we will avoid the last one. So if it was set to dinner, it could only possibly be dinner. No comparison is needed, and we'll drop in and eat dinner. Now let's talk about the interesting way that I wrote the if conditions. As I said before, it's called a Yoda statement. Because when you think about it, you would say, in English, you would say if meal is 0, if meal is breakfast. But we're not saying that. We're saying it Yoda style. We're saying if breakfast is meal. And there's a reason for this. The reason that you would write a Yoda statement with with a constant value on the left, that's 0, it's not a variable. It's called a constant expression. You can't store anything. You can't use it as a variable. So if you forgot one of those equal signs and you wrote this, if you wrote 0 equals meal, you're going to get a compilation error because you can't store meal in 0. Whereas if you wrote it the other way, if you wrote meal equals 0 by mistake instead of meal equals 0, then guess what's actually going to happen? What's going to happen is meal, the value of meal is going to get stored in, or the value 0 is going to get stored in meal. That's going to be the first thing that happens. So you've erased the fact it's dinner. Now it's breakfast suddenly. And 0 is going to be returned. And 0 is, like I said, it's equivalent to false in some languages, in the C family of languages. So it's actually going to evaluate to false. So if you wrote this, if you wrote if meal is 0, that's going to evaluate to false. It's going to drop down. And so now the value of meal is 0. It's going to check the second body. It's going to check the else if. That's going to evaluate to false. And it's going to go to dinner. And so suddenly you're going to be eating dinner 3 meals a day, every day of the week, and you'll get fat probably. And you'll also be very confused about your program. So that's why we use Yoda statements. It protects us from accidental typing errors. I have another thing to talk about here. In some cases, you can rework if statements. If statements are bad. You need if statements, right? You can't live without them. But you want to have as little of them in your life as possible. They're like politicians. You just want as few as possible that you need to get things done. Because otherwise, if you suddenly have 30 else ifs, because you can add other else ifs in here if you wanted to. You can have several else if where several different conditions are evaluated instead of just one. And if you have that, that's a mile long of just else if, else if, else if, else if. That's really bad. It's a bad sign. It's called code smell. And what code smell is it's nothing that's wrong per se, but it's an indication that your program was designed improperly and it needs to be reworked or refactored is what it's called. So whenever you can, try and minimize the use of else of if statements. Keep them smaller. And you can put if and more ifs inside of if bodies. There's nothing wrong with putting another if statement inside of eat breakfast. So you could say, if 0 equals meal, I'm going to type this out in chat. If 0 equals meal, and if I'm hungry, sorry, just going to type this up in chat here. So I would say if 0 equals meal, and then if hungry, then eat breakfast. You could have them inside of each other. There's a limit to how deep you can go, I think, but it's nothing you'd ever hit without malicious intent. So, but it's also bad. You don't want to be doing that. If you start having nested if statements, it's a sign that you're doing something wrong. You should stop, put your hands down, and think about what you're doing. So now switch cases. It's another way to do the same thing, and this is the C++ style of switch cases. They're a little bit more unique beasts. You don't see them used quite as frequently because you can use them just as easily as you can use an if statement. But they're used usually, as I say here, they're used specifically when you're dealing with an encoded value, an enumeration that I was talking about before. That's when they really shine. As you can see here, I wrote, there's a lot more air. There's a lot more white space, which is good because it lets you focus on the actual functional part of the code rather than on this this scaffolding of control statements that aren't important to actually what is happening in the code. If you've got tons of control statements all over the place and you've got just a little handful of functional code, then it's another bad sign. So let's see it again. We've got the same encoding that we were talking about before. And so again, it's lunchtime because the meal is set to 1. And so now we're going to switch on meal. So that's what you say. You say switch on the value of meal. And basically we go from top to bottom. We say case 0, which means if meal is 0, you're going to eat breakfast, but it's not. So we're going to drop down. We're going to fall through to case 1. Case 1 means if meal is 1, then you're going to do what the body is in there, and I've got that commented out as saying eat lunch. And now we have something very important called break. Break means that you leave the control structure that you're in. You can use it anywhere. You can use break to jump out of an if statement, of a series of nested if statements or a while loop or any of these other control structures that I'm going to get into. And the problem is switch cases are very unusual in that if one of them evaluates to true, it's going to keep checking the other ones in case, even if one of them evaluates properly. Now it's interesting here I have default. Default you usually write it down at the bottom, and it means if nothing else is right. And if we're using an encoded system here, if meal isn't 0, 1, or 2, then something is terribly wrong. Something's gone completely wrong. You've got malformed input, you've got a memory stomp. Somehow meal has a bad value, and you should panic. You should print something out, you should make an assert, you should stop the program and yell, there's something wrong here, because you shouldn't be seeing that value. And that's what default is. It means in any other case. And you'll see it doesn't have a break because it's the last thing in the switch case. So there's nothing else to break out of. All right, while loops. And I realize I'm running a little bit late here. I hope you guys will bear with me. I've only got 3 more slides in after this. If you give me just a second here. Are there any questions up to this point? I'll give Chad a second to catch up. Let me know if you have any questions. I know I'm going really fast. Like I said, this is Programming 101 in 2 hours. Not that we're running for 2 hours, but this is going to be about 40, 50 minutes. It looks like it's probably going to wind up being an hour, but then there's going to be a whole part 2 be able to come back to. You what, mate? I can't answer that. That is an invalid question. I guess that's it then. So moving along to control structures, to loops. Loops are great if you need to do the same damn thing over and over and over again. That's why it's called a loop. To accomplish this, and this is generally used if you're consuming something. It's funny I said consuming. I'm talking about hot dogs. Like by consuming I mean something like input, like you're reading a file. Then you would loop through all the lines in the file. You'd say read line 1 and then line 2 and line 3, line 4, etc., etc., etc. Or if you are, I don't know, you see it in math, you see it in encoding stuff. If you need to encode stuff a bunch of different times, you do the same encoding mechanism over and over. Then you're going to use stuff like what do they call it, the cyclone. There's some kind of cool, the twister. The Mersenne twister is a cool encryption mechanism algorithm that uses loops. Now, what a loop will do is it'll perform a body. I say text here. That's really awful thing to say. Ignore that I said text. I'm sorry. I'm terrible. A block of code between its braces until some condition is met. In this case, we're going to eat 7 entire hot dogs. So as you can see here, I must have been hungry when I was writing this, but so we say we've got an integer up here that says we've got 7 hot dogs. We got num of hot dogs is 7. You'll notice that with all my variable integer names, I'm being really specific. So some advice I can give you, and it's right out of the Google C++ style guide. If you're going to be using variables just once or twice, avoid short, unreadable names. If you are using here's some shit for you guys. I had a variable at work the other day that was called this. What the fuck is wifed? It doesn't mean anything. I think that it wound up meaning right. It's, oh, by the way, for the people who can't read, can't see chat obviously in the video, it's WIFD. And I think it stands for right input file descriptor. That is a terrible name. Don't use that. Always favor readability. If you're going to be using something over and over and over again, make it short, but make it readable. You will always forget how your code works. It's just going to happen. There's no way around it. So please do yourself a favor and spend the extra couple of seconds writing a legible English name for something. So that's the end of that rant. So now we're going to get back into the while loop. So now we have while the number of hot dogs is greater than 0. So that's basically what that says. Every time we go into this while loop, the first thing we do is we're going to check our number of hot dogs, which is 7. 7 is greater than 0. That's what that greater than bracket means. Which means we're going to go in and we're going to do that body once. So we'll eat the hot dog. We'll assume that something in there is eating the hot dog, which I'm hiding. And then we're going to take the number of hot dogs. We're going to decrement it. Jay, I'm sorry. Are you seeing some lag? Let me know. Let me know if you guys are getting some bad lag spikes. I will. I don't know. I'll do something. Yeah. So if we'll go back here and we'll decrement the number of hot dogs, and by decrement that's the opposite of increment. So that means to decrease by 1. Okay, cool. Now another way you could write this, and I didn't write it this way because I don't know all languages support this, but you can use the minus minus, the post decrement, or the pre decrement. So I could have just as easily written that line as this. And what that's going to do is that is going to take the number of hot dogs, it's going to decrement it by 1, and it's going to save it to itself. So it's literally, almost literally, there's some very funny things about how post and pre and post decrement works, which is the reason why I didn't add it in here. But just be aware that you can see syntax that looks like that, or syntax that looks like this. And if you see it, those two things unfortunately mean two very different and importantly different things. So if you ever bump into something in a dark alley that looks like this, look it up, because it has some unique meaning. So now we've decremented it. So now the number of hot dogs is 6, and we go back up to the while loop. So we jump back up and we check the loop condition again. That's what that body in between the parentheses is. It's called the loop condition. So now our number of hot dogs is 6. And 6 is greater than 0, so we're going to eat another hot dog. And we keep doing this over and over and over until we run out of hot dogs and we're very full. Yeah. Now, the thing about while loops, they're generally used with a function call in the body. You don't usually see them alone like this. This could be more properly written as a for loop. When you are writing loops, you're gonna fuck up. There's no way around it. At some point or another, you're going to write this instead, which I'm gonna say this out loud. You're gonna write if while number of hot dogs is greater than or equal to 0. It's different. So you'll see that if the number of hot dogs is 0, then it's not greater than 0. So you're not going to eat a hot dog that isn't there. But if by accident you actually accidentally use the greater than equal to symbol operator, which is just a greater sign than an equal sign, then you're going to try and eat a hot dog that's not there, and the world's going to crash or something like that. I don't know. Or you can try eating a hot dog that's not there and just look like an idiot. But that's called an off by 1 error. And you're going to see them all the frickin' time. So whenever you're writing a loop, stop and put a little bit of thought into making sure that you're using the right comparison operator in there, because otherwise you're going to run into this silly thing. And usually it winds up being a segmentation fault. That's the numero uno cause of seg faults. And I'm not going to explain what those are. But if you see one, that's probably what it is. So there you go. I just fixed your program for you. Moving along. For loops. For loops are the most common kind of loop. You don't see while loops nearly as much. But you see for loops. And they present a terse syntax for the most frequent scenario in which loops are used. They allow for an initializer, a condition, and then a statement to run at the end of each loop iteration called the afterthought, which is interesting. I never heard of that before writing this, doing my research on Wikipedia for that. So here's our example of our for loop. And you can see int num hot dogs equals 7 is our initializer. Num hot dogs is greater than 0 is our condition. And then there you go is the minus num hot dogs, the pre-decrement. Num hot dogs is the afterthought. So you can see that these are equivalent, actually. Almost equivalent. There's actually a big difference here. So first off, we're going to see back here we were setting the number of hot dogs to 7. In the for loop, we do it as the first part of the for loop, as the initializer. And then it has the same thing as a while loop. It has the num hot dogs is greater than 0. It's the same thing we had before. There it is. Num hot dogs is greater than 0. Oh man, I can't use my mouse. I forgot about that. I wonder if I can... it doesn't look like it's going to let me do that. Alright, well, damn. Okay, well, anyhow. And then finally, we have the after... Well, okay, so now if these two... It runs the initializer once. Just once. And then it checks to see if the number of hot dogs is greater than 0. Oh, so the initializer. So you can't see what I'm pointing at. Jeez. The initializer, num hot dogs equals 7. It only sets that once. It sets that before it evaluates the loop condition for the first time you enter. So then it says number of hot dogs is greater than 0. And it is, because, it's 7. 7 is greater than 0. And it's going to go move into the body and execute the whole body. It's going to say eat the hot dog. And then it's going to come out and it's going to run the afterthought, which is minus minus num hot dogs, which is, as I said, is for all intents and purposes for us right now is equivalent to this num hot dogs equals num hot dogs minus 1. Same thing. You see here I have a pre-decrement instead of a post-decrement because that's actually more, it's going to be more efficient than writing a post-decrement here if you want to get fancy. If you're doing a post-increment or post-decrement, either way, a pre-increment, same thing, it's just a plus plus instead of a minus minus. Which is going to be more common. You're usually, in your for loops, you're usually going to be making a small number. It's usually going to be an int x equals 0. There's going to be some integer that sets as 0, and it's going to be moving and becoming more positive because you're usually going to be operating on various different parts of linear sequence of data that you refer to by these increasing 0, 1, 2, give me the 0th or the first thing, give me the second thing, give me the third thing, until you're out of things, except in this case I don't start with hot dog 1, I start with hot dog 7. So I use the pre-decrement there, and that's actually going to save you a little bit, it's going to make it a little bit more efficient. Just something to keep in mind there. So hopefully that's pretty straightforward. And actually, that's all I got for now. That is the whole first part of this. Gonna come back up to the beginning. So we can see here we talked about all these different data types, all the different control structures. That's it for our first part. In the next part, we're going to be talking about functions in scope, arrays in memory, compilers and interpreters, recursion, object-oriented programming. I'm going to give you some advice. I'm going to give you some good books and resources where you can learn yourself if you want to. So for now, I'm going to open it back up to questions. Does anybody have any questions about anything I went over? Or anything else tangentially related to programming? I can try and help you out here now. Okay, not seeing anything in chat at the moment. Getting a little bit hoarse here. What is Novice Now? Oh, that's a great question. Novice Now is let me see if I can come up to the, what is the difference between C and C++ and C#? That's a good question. I promise you I'll get right back to that for once I answer what Novice Now is. Novice Now is a game jam that we're hosting on itch and GameJolt that is geared towards people who are picking up programming and game design for the very first time. It's non-competitive. It's set as a collaborative educational game jam where there's no judgment. You don't have to be worried about working with people who are industry vets. And hopefully you'll be able to get, you will definitely get as much access to people who have some industry experience or programming knowledge as you want. You have the administrator's email addresses, and you can get in touch with us anytime you need some help. So if you're interested in that, you can just Google the Novice Now, which will let us know it's a little bit late, but feel free. We have an IRC chat that you can drop in and get in touch with us anytime you want, which is pound Novice Now Jam on Freenode. How to access the IRC if you never used IRC before. look us up. Our itch page has all the information you want about the jam and how to get in touch with us. Now moving on to you, J-Ben. What is the difference from C and C++ to C#? Well, first off, C and C++ are two different languages themselves. C came out, its predecessor was B, actually, and there was an A language as well. It was designed at IBM, I think, designed it back in their labs. You can correct me if I'm wrong. By two guys, Kerrigan and Ritchie, I think. They were the original designers of the C language. And it was the programming language, the one programming language to rule them all. It's the godfather of all programming languages. It's a very powerful language. It's a very expressive language. You can, no, it's not very expressive. It's very powerful. You can use it. It's very, very generalized. You can use it for just about anything you want, but it's going to be hard because C is so old. C++ introduced object orientation, which means it has classes, and it has more. It's more abstract than C, which basically allows programmers to write in a more modern idiom than in the C language. C isn't object oriented. It's called an imperative programming language. No, it's a functional programming language. I believe I said that wrong. Yeah, I think Lisp is imperative. I might be wrong. But yeah, so C++ introduced some things. It introduced Booleans, and it introduced a standard library, which is basically a bunch of different containers, algorithms, built-in functionality. With C, if you just have the language, good luck. There's not a lot in there. There's a lot of system-level stuff, like interfacing with the computer, allocating memory, allocating memory, dealing with file system, opening files and reading, writing, the internet, all sorts of different stuff, using the keyboard, drawing to the screen, input, output, basic system stuff. But above that, there's nothing really nearly as powerful. You basically, if you want a data structure, you got to write it yourself if you're in C. And even then, there's not good ways of writing complicated data structures like you can in most modern or object-oriented languages. You only have structs, which are basically structs are basically objects, classes without constructors, destructors, or methods, or visibility. So they're a lot more work to deal with. C++ introduced all that. You have the STL containers. You have the standard template library that's got stuff like vectors, linked lists, hash maps, sets, all sorts of different stuff, pair, all this different stuff that you basically use as really generic data structures that can be used for just about anything. And in addition to that, it added a whole bunch of other functionality to make things a little bit easier. And Booleans, for goodness sake, you finally have Booleans in C++. Now, C#, I haven't used it a ton, so I can't go as far in depth into that as I can in C and C++. But the difference with C# is the major difference is that it is it has a managed memory model, which, like Java, it's got a garbage collector. So if you are creating objects and you run out of references and you're not using the objects anymore, it'll clean up those objects for you. C# is designed to be a little bit safer to use than C++, mainly because it separates you from the need to do memory management yourself. Other than that, like I said, I really haven't used the language very much. I've been using it a little bit in Unity recently, but I can't really help you out much more than that. I'm sure if you looked up the language, there'd be tons and tons of comparisons to see how they're different. But yeah, I believe it just presents. I think that it's supposed to be similar to .NET. I don't know if that's if that's wrong or not. But yeah. Yeah, so does anybody else have any questions? We're sitting around 1 hour and 5 minutes. I'm sure you guys are all completely exhausted of hearing me talk. Let me know if you have any questions. And if not, if any of you are interested in seeing more webinars or participating in the jam, let me know, and I'll hook you up with all of the juicy details.